Good afternoon, everyone, and a Happy New Year to you all. Thank you for joining us for our first seminar of 2021. Today's event is jointly organized by the EuroCC and SimEA ERA Chair projects, which both fall under the Computation-Based Science and Technology Research Center at the Cyprus Institute, and which has also recently become a National Competence Center in HPC. Today we are joined by Dr. Christodoulos, who is our Managing Coordinator, and he will give an overview of the newly established Management and Innovation Office at our center, and will highlight how the industrial and governmental sector can use HPC to further their research in a variety of ways. I would like to give a bit of background information. Christos completed his bachelor's and master's degrees in physical natural sciences at the University of Cambridge in the United Kingdom, and then a PhD at Humboldt University in Berlin under the supervision of Professor Koch. After a postdoctoral research fellowship at Helmholtz, he transitioned to industry, in particular to motion logic, where he has held a number of different positions. He started off as a data engineer and then led a research and development team, and finally worked as an engineering manager leading a team of data scientists, analysts, and software engineers. He acted as product manager and relationship manager. Christos, thank you very much for joining us today. I will now pass over to you.
Hello. I hope you can hear me.
We can.
Thank you. So nice. So thank you, Kathy, for the great introduction. And also good afternoon from my side, and welcome to the first event. Welcome to the first event of the SimEA and EuroCC seminar series of 2021. A very warm welcome to the first comers, if we have some, and I hope you're all welcome, and I hope you find this seminar series, this talk and this seminar series interesting. As Kathy mentioned, my name is Christodoulos, and I'm working as an Innovation Scout at the CaSToRC Center of the Cyprus Institute under the SimEA project. And if you are new to these abbreviations, do not worry so much. I hope afterwards during the talk you will. It is going to be clear what this project source center is. The outline of the presentation is as follows. So the idea today is to give you an overview of the CaSToRC Center, and then a high-level introduction on how HPC can facilitate innovation together with computational science and engineering and AI. Then I want to give some examples of recent ways that companies have used HPC to achieve, let's say, breakthroughs or innovations. And then I will move on to talk about the newly established Management and Innovation Office under the CaSToRC Center. And then we'll proceed to talk about the innovation actions that are planned by the office and some of the upcoming projects. So again, welcome everybody, and let's start. So as a motivation, I want to pose the question first, mostly to people that are not so familiar with high performance computing. So one question is why would a company, or why would we need to use high performance computing? And a very good and recent example where HPC showed its, let's say, necessity is fighting the COVID-19 virus during the recent pandemic. So if you use the keywords COVID-19 and supercomputers and do a Google search, you will find a lot of articles about how researchers have used the computing powers of supercomputings to help find treatments for the virus. So really what HP is for is to enable to tackle large scale and complex problems. The massive computation power offered by HPC in combination with modeling and simulations and AI can help scientists rapidly advance their understanding of the COVID-19, leading to accelerated development of new treatments and preventative measures. So really never have supercomputers shown their value to society more than I would say during this COVID-19 pandemic. So really researchers have used HPCs to explore the virus at the molecular level, and they were able to forecast the spread of the disease, and they were able to design drugs to combat the virus much faster than would be otherwise possible. With that, I hope I gave you the motivation why using HPC would be important. And with that, I want to proceed to an overview of the CaSToRC. So CaSToRC stands for Computational-Based Science and Technology Research Center. It was created in 2019, some years after the establishment of the Cyprus Institute. And it's currently one of the 4 research centers of the Cyprus Institute. It hosts more than 30 researchers with a variety of backgrounds, and it's very successful in gathering funding from external sources. During its operation, the center has secured more than 16 million euros in external funding, with the majority of them coming from the European Union. And so the center has, let's say, a dual mission. One is to provide computational-based research and education. And secondly is to provide computational resources and know-how to user communities. And with user communities, we're talking about companies or academics or really any sector that really want to use computing time from the HPC facility to solve a particular problem. CaSToRC has been recently designated as the National Competence Center for HPC in Cyprus. So this is part of a pan-European HPC action involving 33 countries, and the aim is to advance scientific discovery and innovation. And just to show the kind of the scale and the importance that the European Union pays in that project, the upcoming budget for all the countries that are involved in the project is around 8 billion euros for the next 10 years. And this funding this is co-funded between the European Union and the member countries. So one of the projects of the European HPC joint undertaking is called EuroCC, and EuroCC aims to enhance the European uptake of HPC by academia and industry by creating NCCs for HPC in each member country. And for Cyprus, the competence center, as I mentioned, is CaSToRC. Apart from becoming a national competence center, CaSToRC hosts the prestigious ERA Chair project, SimEA. ERA Chair projects are, again, European projects that aim to bring excellence to institutions and universities by bringing outstanding academics under the direction of the ERA Chair holder. So one of the main goals of ERA Chair projects is to implement structural changes necessary to achieve excellence on a sustainable basis. moving forward to what the research scientists or the computational scientists at the center work on, they tackle a variety of fields ranging from fundamental physics like nuclear and particle physics, or fluid dynamics, computational dynamics, to scientific computing and novel architectures, computational biology with visualization, climate, environmental modeling, digital cultural heritage, and also big data and machine learning. In particular, for the big data and machine learning, there are computational scientists with a lot of expertise in the field of computer vision. So really the expertise of the center span a great deal of areas. And in addition to the current research areas, the SimEA project adds the additional area of computational engineering in the portfolio of CaSToRC. So the focus of SimEA is on the modeling and simulations of materials that are close to reality up to a very good level. And this is a kind of a strategic addition to the portfolio from an innovation perspective, because in addition to the existing infrastructure at the center, which is there already, the SimEA project offers the scientific knowledge by developing the computational models and simulations for novel and innovative materials, more specifically in the area of soft matter. So after talking about the research areas under CaSToRC, one question that that can come up is why would computation be important in nowadays? And so over the past several years, computation has been shown to be an essential tool for accelerating the development cycles in research and businesses. And computation is really becoming increasingly important for our understanding of the world we live in. And as a matter of fact, it has been termed as the third pillar of scientific discovery, together with theory and experimentation, which have been there for a long time. So why is it so important? If you imagine how research was conducted without computers, so one had to study the properties of, let's say, product on the basis of prototypes. And to do that, researchers would need to do experimentation and understand the theory of an immense number of prototypes to be able to find a product or a prototype that would be of relevance for its properties. Now, what computation helps is to first come up with a lot of prototypes and simulate them on a computer before coming to let's say a more narrow selection of properties to develop materials in the lab. So this really accelerates the progress immensely. Now, why is HPC important? High performance computing is necessary to model and simulate complex problems and physical phenomena such as weather, fluid dynamics, and molecular interactions. Together with the research interest in HPC, we see that it's important for industrial uses as well, as industry can leverage HPC to improve products, reduce production costs, and decrease the time it takes to develop new products. And really this results in the acceleration of the production time from days or weeks that was before down to minutes or hours. Another reason why HPC is important is because of the high amount of generated data on a daily basis. As you can see, the average internet user, these are approximated numbers projected for actually last year, and the average internet user generates around 1.5 gigabytes of data each day. That increased from around 600, 700 megabytes 5 years ago. And you can see that the self-driving car generates 4 terabytes of data a day, each car, and going down to smart cities and connected cities, a connected factory would produce 1 petabyte of data each day. So we are quite greedy in the way that we generate data, and to be able to process this data in a meaningful time and in meaningful ways, the HPC plays an important role for that. So how does HPC work? It's in theory, it's quite easy. So thousands of processors work in parallel, delivering millions more of computational power than, let's say, for example, a workstation or a personal computer. How is this done? A user can prepare a question, can formulate a question as with as much detail as possible, and then that question is passed to a supercomputer, where a scheduler splits down the question to smaller questions and distributes it to different nodes. And these nodes work in parallel to answer these questions over and over again. At the end of this cycle, the supercomputer will generate data, and so these data can then be stored in the data storage and be used to, let's say, make decisions. As you can see, in the recent years, there is a lot of uptake of HPC in different fields in research or industry, because so HPC has been traditionally used in areas like physics, astronomy, chemistry, engineering, material science, where scientists use HPC to conduct research and solve complex problems. And increasingly, we see biology, genomics, AI, financial, weather, and other sciences to use HPC. Now we even see sciences like humanities that use HPC to solve their problems. And this uptake shows how different fields can leverage HPC together with AI and simulations to solve their problems. So after that, I think it would be interesting to see some more concrete examples how HPC together with AI and computational science and engineering help solve complex problems. And for that, I would like to start with some examples from materials design, because these are materials we can find on an everyday basis. And to design and develop these materials, most of the times the introduction of HPC at some point or in the workflow is needed to come up with this material. So one example of these materials is polymer nanocomposites. This is also one of the materials that are under the expertise or portfolio of the SimEA project, which are nanoparticles dispersed in a polymer matrix. this multi-component material leads to better properties of the nanocomposite material. And one can find applications of these materials just outside the door in a variety of fields, food packaging, biomedical, and as you can see in the picture, in car tires. Another interesting field of materials is graphene-based nanostructure materials. Graphene has been discovered some years ago, more than 10 years ago, and the scientists that worked on the discovery, on experimentation of graphene won a Nobel Prize for it. They have been researched very strongly, and they have nowadays, scientists nowadays are able to produce real-life applications with graphene, like in organic electronics, gene therapy, bioimaging, and so many other fields. And again, after the design and the development of these materials from using HPC components, we can see materials and products coming that use these components in our everyday life. One example is, again, face masks that work against COVID-19 and other viruses. So for this type of masks, one form of graphene is used, and what these graphene sheets are doing is that they can kill the virus up to a sensitivity of 98%, which is of paramount importance for the advancement of disease control and prevention. Another field of materials are polymer thin films. Again, materials that can be found in everyday applications, from food packaging to electronics. These materials are most of the times smart materials that they can be designed to change their properties at different environments. One, again, everyday example is chrome-active glasses that change their color when subjected to a certain variation in temperature, light, or pressure. The example here are glasses with a coating, so a thin film on top of them, where the color darkens when they're exposed to more UV light. We see a lot of innovation by using HPC in medicine. I mentioned before the COVID-19. So HPC was used for a virtual screening to rapidly identify compounds that can find the virus. Simulations were used to test the interaction between molecules and the virus active sites, and this was facilitated with the massive computational power of HPC facilities. And of course, machine learning algorithms were used to bring more accurate physics-based and tractable models in the game. One example of a European project that used HPC to help identifying molecules was actually one of the most powerful industrial supercomputers in the world, the Ennis HPC5. So with that, scientists managed to simulate 5 million molecules per second. And of course, being able to simulate so fast means being able to accelerate the identification of compounds that can find the disease. Apart from medicine and materials, we see a lot of businesses using HPC in their workflows. Nowadays, the banking sector and also finance sectors are full of complex problems coming together with a massive amount of data. What is happening is that the intense level of data, there is an intense level of data processing necessary to comply with new regulations that can change abruptly, and this has resulted in a rapid uptake of HPC in the banking sector. One example of this is risk assessment, where new regulations require more detailed models, and of course this leads businesses to be involved with HPC workloads to come to a, let's say, competitive advantage with respect to their competitors. Another example is oil and gas, the oil and gas sector, where finding, producing oil, and optimizing the production of oil is computational intensive problems. And with the help of HPC and AI, one can reduce the hours of calculations to minutes and help enterprises rapidly adapt to market changes. So here, for this field, we're talking about the generation of exabytes of seismic data that they need to be used for the discovery and extraction of oil. So again, with ML algorithms and HPC, the efficiency and speed of exploration and drilling and production is immensely increased. Another important and kind of general field where HPC together with AI is used is in the effort of businesses and organizations to digitally transform. So, for example, advancing fields in like natural language processing and computer vision can help automate various problems to help industry and government in their effort of digital transformation. And this involve tasks like language translation, voice text conversion, creation of human-like conversational agents, objects or image classifications. And this can create a lot of applications resulting in the reduction of administrative work, optimization of internal operations, and so many other fields. One example of in the natural language processing is how let's say the language models that are being developed in a really fast pace, they have an increasing amount of parameters incorporated in the model, and actually the number of parameters of these language models increases faster than the growth of let's say GPU memory improvements. This really means that let's say the horizontal scaling of the algorithms will be needed for developing of these language models. And to achieve this horizontal scaling, one would need to resort to parallelization of the task at hand. Now, coming to the question of what CaSToRC will do to foster this innovation with this in these fields. The main scope of the National Competence Center, together with SimEA, is to advance competitiveness in research, improve the effectiveness of government services, and importantly, to promote innovation by engaging with industry. The above items will be pursued through the SimEA project and the Euro HPC with the help of a newly established Management and Innovation Office under the CaSToRC. As I mentioned before, the MEO stands for the Management and Innovation Office. So the scope of this office is really to forge links between academia, government, and industry, and the overall innovation ecosystem in Cyprus, using the CaSToRC's expertise in HPC, AI, and data science. In addition, under the scope of the office is to enhance the research and management structure of the center by optimizing the mobilization of resources and personnel to be engaged in the center's innovation programs. As a long-term vision, we want to establish CaSToRC as a one-stop shop for local, academic, industrial, and government stakeholders to integrate HPC and data science approaches in their workflows. As a structural change, MEO is an office that is established under the CaSToRC Center. As you know, there are many research centers under the Cyprus Institute, with each one having their own internal structures. And the Cyprus Institute also has its kind of overarching structures that also coordinate with the research centers. So the scope of the CaSToRC is to also collaborate and enhance the Cyprus Institute structures. For example, the Research and Innovation Management and Support Office and other innovation and entrepreneurship related offices. And the aim is not only to enhance this internal communication, but also to, of course, link with small, medium sizes and large size enterprises, governmental organizations, and the whole startup ecosystem in Cyprus. One of the first actions of the MEO office when it was established is to perform a market analysis for Cyprus. And I want to present here two of the main findings from data taken from the Cyprus Statistical Service. As you can see, the recent years we see an increasing amount of companies resorting to cloud providers to use their computing power to run their software. So we see that the number of companies resorting to cloud providers doubled in the so between 2016 and 2018. And these companies are actually targeted to the center's innovation actions, and we are actively talking to this and scouting for companies that we find that they would be interested in using services provided by CaSToRC, by the high performance computing facility here, instead of resorting to cloud services. Another important finding is the increasing amount of companies analyzing big data. Again, companies ranging from small to large companies. Again, as with the companies utilizing computing power in the cloud, these companies will potentially benefit from the use of HPC. The MEO office, together with the industry support team, is comprised of Kathy, Andreas, me, Stelios, and Kyriakos, all members of the Cyprus Institute and the CaSToRC Center. And the idea is for the office and the team to be expanded in the future, to be able to work with an increasing amount of projects coming either from industry or from the government or from academia. For more information, of course, you can find the links to the user support below. Of course, more people than these 5 people are involved in these actions. And if you want to have a look at the people working under CaSToRC, please visit the last link there. Now there is a number of innovation actions planned under EuroCC and the SimEA project, and this is a list listing the main actions we plan to do. The first thing is to raise awareness of the potential of HPC through seminars and interaction with the CaSToRC personnel. And this, for example, this seminar series is designed for raising awareness and making people understand why HPC is either needed at the moment or will be needed in the future for their problems. We will have a training program with courses on HPC, a lot of hackathons and hands-on software development. We provide access to local HPC resources and services here at the HPC facility of the Cyprus Institute. We want to provide consultancy for technology transfer and business development, as well as co-development of code for projects that can be collaborative projects between the center and industrial partners, as well as an internship program for people to work closer to the research scientists and computational scientists at the center to solve a defined problem. And one of the kind of the long-term aims is to help users and support users to scale their software, not only locally, but using also European machines and access exascale resources in the future. So there are a couple of existing or upcoming projects. So as I mentioned, we have been engaging with industries, and we are trying to understand the needs of the, let's say, the industrial Cypriot landscape. And at the moment, we started working on a real estate value prediction problem and a leaf disease classification problem. So together with industrial partners and government organizations, we started these, let's say, problems involving mostly HPC and machine learning. And in the area of computational engineering and science, there are several projects. For example, the design and development of plastic bags from bioplastic or waste material, and the development of next generation car tires with a company of international range. There are a lot of upcoming events. There is an industry week that is going to occur in March 2021. So this is aimed for mainly people from industry, but not only. We would be very happy to see people from academia joining the industry week, as the idea is to have a user forum, and then discuss with industrial partners and identify potential problems by sitting with them for a longer time to try to understand how we can form projects with them. We have trainings for industry and academia, with the first one in February 2021. And we have the seminar series. And on the right, I also have the program for the time until April 2021. It's going to be updated afterwards. And for more info on the upcoming events, you can visit one of the websites at the bottom. And also, if you are interested in working at the Cyprus Institute, you can visit the job board of the institute. We have recently created a Meetup page, and so you can use the link here. The idea is to have this page to publish all the events, and I would highly recommend becoming a member there, because it's a way to stay in touch with the events and get notified of upcoming events. And it's a good way to track what's going on. And with that, I want to give some credits for some images I used in the presentation. And I would like to thank you for attending the meetup, for attending the event. And if you have a project that you would think that is computationally complex, we would like to hear from you. And so please get in touch using the emails below. Thank you very much. And I think now if there are any questions, you can unmute the mic and ask them. Alex?
I guess,
yeah, go ahead.
I guess you mean me.
Yes, Alex and yes.
Alexander, sorry about the username. I mean, you gave a lot of examples, Christos, which are very useful. But however, I would like to understand a little bit, for example, with this mask that you showed,
yes.
What were the, I mean, can you tell us what the computational resources and algorithms were used for that particular case or for some others, just to get an idea of the scale of the computational effort?
I don't know about the mask in particular, but for the, I think for the, yeah, for the, I don't have a lot of details on the kind of the resources that have been used. I think that has been done recently, and they have used. I think it has been developed in, yeah, I believe in Asia. But yeah, I'm not sure about the computational resources that have been used for this particular example.
Okay, but you know, for the AI applications, it would be nice to understand how you would scale this in a truly HPC environment. I mean, truly HPC environment means that you use also, you know, not just trivially parallelizable kind of application, but in a more robust way. And I don't know, do you know any developments there? I mean,
yes.
the people who did this with the COVID-19 on Summit, I mean, do you know any sort of development where they really used HPC in the sense of a couple
Yes,
system?
for example, for the exascale for COVID, they used really more detailed parallelization, not trivial.
Okay, but it was for the machine learning part, or from the for the rest of the components?
So for the exascale, it was mostly for simulating the molecules. So it was mostly on the simulation. But for example, for the language models that I mentioned under the topic of digital transformation, so this was one of the biggest models, which is the GPT-3 language model. So they haven't, at least I haven't found whether they have opened the way they did it, but if it was done by only trivial parallelization, that would result in years to be able to finish. So we are waiting to understand what kind of parallelization they did to manage to compute the model so quickly, and that was in the field of deep learning and natural language processing.
Okay, thank you. This is very interesting. Thank you.
Anybody else?
May I ask something, Christos? Can you hear me?
Yes.
Yeah. Okay. Yeah, thank you very much for a very interesting overview. I'm just thinking now more practical, let's say from the point of view of SMEs or industries. You have already that the CaSToRC as a national competence center, and me also will be a, I mean, the idea is to have to be a national focal point. Can you just comment or describe a little bit the procedure if there is an SME that finds an interesting problem, that has an interesting problem or an industry, and considers MEO and CaSToRC as potential collaborator? What they should do, what someone should do in order to contact?
Yes. I mean, the first thing is to come into contact with us. I have the emails at the end of the end of the presentation, and then what is important is to start a discussion with them to understand the needs, to understand the problem more closely, and understand the needs of that problem. In that case, we would like to understand what kind of disciplines or expertise would be needed to solve that problem, whether it would be, let's say, in the field of machine learning and computer vision, or computational engineering and so on. So the idea is to have a couple of detailed discussions with them to understand exactly what they want to do and what we can offer for them. And as soon as we have a clear understanding on what is the problem, we have a lot of different ways to support them. And as mentioned here, depending on the nature of the project or the nature of the collaboration that is needed from the company, we can use the center's expertise to transfer the know-how to the company by a training program. We can provide consultancy. We can provide code development for these projects, or internship programs. I'm not sure, Vangeli, if that answers the question.
Yes, yes. And if I may add on that, Christos, that of course we don't exclude academia, because I assume that most of them are from academia. That's it. Of course, we also want to develop new and to foster existing, let's say, collaborations with other research groups from academia. Yes.
Can I ask something? It's Michael Papadopoulos here. Christo, what is the business model that is foreseen for such kind of services? I mean, do we seek to provide these services with a fee-for-service model? Is there room for support within the projects that you mentioned towards companies here? What's the business model behind this service provision?
So there are, again, a lot of different ways. Again, for example, with a code development project, the idea there would be to have a fee for the development of the code. And on the other hand, for example, for the internship program, that can be an intern can come and be attached to one of the projects, for example, the EuroCC project. So the idea there is to have an intern and train them and transfer the know-how to an industrial partner that way. So there are a lot of different ways, and yeah, at the moment the kind of the business model is not entirely clear. So it's something that is being continuously built, I would say, as the kind of the interaction with the companies is only now, let's say, becoming more mature. So now we kind of start understanding what are the ways that will be the most efficient to work with the industrial partners or academic partners or government organizations. I hope that answers the question.
Thank you.
Andreas has a question. Would you like to ask? Oh, okay. So Andreas has microphone issues. So I'll read out his question for you to answer, Christo. Andreas asks, it was mentioned that self-driving cars and aeroplanes produce terabytes of data per day. And out of curiosity, I'd like to ask what kind of data they produce and why they are of so large size. So are they oriented for AI research from the manufacturers and so on?
Going back to the slide. So, for example, the self-driving cars. I think the main data format they produce is video, and that results to this amount of data per day. And yeah, a connected factory can have anything from images to video to text. But at least at the moment, the data, they are mostly unstructured data, and they are not really structured in a way that they can, let's say, be analyzed by traditional methods. So, for example, there is a vast amount of text data and structured data coming from this, let's say, from a connected factory. And yeah, to do that, so they are really unstructured. They can be log files, they can be written communication, they can be everything. And so yeah, at the end, as I mentioned, we are quite greedy in producing data. So it's also not necessarily true that all of this 1 petabyte of data would be useful. Maybe a small amount of this data will be useful after being analyzed. I hope that answers the question.
Yeah, suppose the car, for example, self-driving cars, they collect data which the manufacturer could possibly use in the future to create better cars, diagnose for safer driving, basically, I believe.
Well, the self-driving cars, I mean, they record everything, right, as they drive.
Yeah, I believe they do, yes.
So that's, I mean, for that they need to really analyze this data coming in as fast as possible. I mean, as they are used to help them make decisions. Any more questions?
I have a second question, Christo. It's Michael here again. Do we have a picture regarding the other national players in this domains, other providers of similar services towards SMEs? Because at some point you mentioned that the companies are using cloud facilities.
Yes.
Does that mean that there's no other similar facility in Cyprus, or are there also other players that offer the same type of services that we are?
Yeah, I believe that at the level of computing power that we have at the institute, no other places have it in Cyprus. Maybe there are places that have smaller clusters, but I'm unsure about the computing power they can provide. But I think the majority is, you know, Amazon and Google and Microsoft, which, I mean, they are cloud providers, so one can use their infrastructure in the cloud. And as far as I know, Amazon is building an availability center, so they are building infrastructure in Cyprus in the future.
But the provision is only in terms of HPC core time. The package that you mentioned, including consulting, including user support and so on, I understand that these cloud providers are not providing this package, or am I wrong?
They do not. They provide, of course, user support, but not at the level that we want to provide it. I mean, for Amazon, you I mean, of course, it's everything more automated. You get into a queue and you have to wait until you are being served. But they just provide support on let's say infrastructure problems, and they would not help in, let's say, co-building an algorithm.
Hello, this is Vasily speaking. I have a question.
Hey, Vasily, please.
First of all, thank you for this comprehensive overview, Christo. My question is, do you need thematic specialization, subject matter expertise in order to be able to support the companies to exploit HPC resources and facilities? You mean, do you need to be able to understand perfectly their own field of expertise and activity?
I wouldn't say that we would need to understand the field of activity perfectly, but we would need to understand it up to a certain extent, I would say, to be able to, I mean, if we want to help them solve one of the problems that falls under their domain, let's say, we would need to have some sort of expertise in their in that area. For example, it might be, let's say, computer vision, it might be designing novel materials and so on. In some cases, that would be useful in designing a project with them. In some cases, if, for example, a company just needs to scale up their code, then again, I guess the expertise needed in that field would not be required to be so high, I would say. But it really depends on the problem that the company would have.
Okay, thank you.
Any more questions? Okay. Thank you everybody. Thank you for attending. I think it's also 5 o'clock, and I hope it was interesting for you, and I hope I will see you in the next seminars. Thank you very much, and have a nice evening.
Thank you again, Christos, for your presentation. Thank you everyone for attending our seminar. We have another seminar next week by Professor Daskalakis from Debak University in Cyprus. He will be talking about his research, partly in his research against the COVID disease that he got access on the PRACE systems to carry out research, but also on his other work on structural biology. So that will be again at the same time at 4 o'clock next Tuesday, and we hope to see you again there. So thanks for joining, and we'll talk again. Thank you, Christo, also.
Thank you very much.
Bye, everyone.
Bye.
Bye. Thank you.
Bye.
Thank you. Bye.